So I thought in that aspect, instead of me telling the applications of AI and focusing into it, I would like to show you some TEDx video. It's a 10 minutes video. The Northern University Professor K, he is a very good researcher in the domain of artificial intelligence. How we can recognition. So I thought in that aspect, instead of me telling the applications of AI and focusing into it, I would like to show you some TEDx video, 10 minutes video. And the making a living being, that is animal or human being. Okay. The color structure of the line, how it is coming. So these are patterns internally. What machine learning algorithms are doing, they are finding the patterns in the data sets. So the pattern recognitions, we are doing a lot. So they are doing a lot of research into the direction. Please go through the video. So once again, I am saying thanks to the management and the organizers, and Sagar, who is also very young and enthusiastic person. So they are all contributing for this conference rigorously for the success. So, and the audience, we are patiently listening so far my speeches. Thank you once again for giving this opportunity. So please raise up your voice is there?
You might say it's because it's red and blue. Yeah, I'm a computer scientist, and so when I look at stuff like this, I actually get pretty excited. You might say it's because it's red and blue, binary, tingle, tingle. Or that it's a network problem. It actually represents a solution to a pretty complicated network problem. That's kind of exciting as well. It's actually difficult to figure out which one should be red and which one should be blue, believe it or not. That's pretty exciting also. But what's really exciting is the way to solve this puzzle, this problem. It's a very hard problem, in fact. The motivation for that comes from the development of the fruit fly's brain, actually. As the brain is developing, there's chemical signaling going on, and the way that happens, and those signals determine what brain cells become, what types of brain cells. It's a very similar problem that the brain of the fruit fly is going through. And the solution for that is actually has been used by computer people to solve these types of network problems. So what's beautiful about that for me, it's not the red and blue, and it's not the wires all over the place. What's beautiful is knowing the process underlying the solution. Now, in nature, most of the beauty is right there on the surface. It's been an inspiration for artists, architects, poets, scientists, you name it, for centuries. You're right there on the surface. But below the surface, there are layers and layers of biological processes that run on many different time and spatial scales. And in terms of time, you've got things going in seconds, minutes, hours, years, centuries, millennia. All these different processes combine to create the beautiful patterns that we see here. Now, once scientists began to understand these patterns, and understand the patterns and the processes that created them, that combination, that's when the beauty of nature really took on a deeper, more profound meaning. And this was first done by a man named Darcy Wentworth Thompson about 100 years ago. He put out a book which is still considered one of the great books in all time in science. It's on a lot of top 10 lists and stuff like that. So there are a lot of different patterns and processes actually that make different types of things. But there's a common theme in all of them, and this is this concept of emergence. And you've probably heard it before, it's a popular science term, and also scientists use it all the time. Emergent systems are systems in which there's a global pattern that comes about, but there's nothing in the system that understands the global pattern. All the individuals in the system, all they understand is their local interactions. Okay? So this flock of birds, for example, they don't understand what a bee is, okay? Or an X or W or anything else. Okay? All they really know is they like to follow a leader, and for energy conservation purposes, it's best when you're following a leader to be a little bit behind and a little bit to the side, and they each follow that basic same rule they all use, and together emerges the bee. Okay? Now these bottom-up constructions most descriptions in the history books of the birth of modern computing, they show a tight tie to World War II. The technology in the war was developed, and it was computational development during that period. The whole concept of nature is inspiration is from a long way from World War II. Quite often, people get a computer, we look at computer applications, they seem about as far from nature as they can get. But going back to the early days of computing, we actually find that biology and psychology were really important topics for the people who developed computing. They envisioned very lifelike machines, such as a number of computers. So for many computer scientists like me, going back to basics, actually.
So one word I would like to say on this video, it is little lengthy anyhow, you can have that link and see personally from your mobiles or anything. How these natural patterns are, we are trying to mimic. See, whatever the algorithms we are finding, the origin is the idea where it is coming is from the nature. So nature is helping us to give lot of research problems and solutions. So lot of research funding even in India or US or anywhere only to address societal problems. Profit conditions, one of these are like this. Medical domain, lot of pandemic situations. Any problem, societal problem, if you are going to address, crores of worth rupees projects are. For that, how do you get the solutions? If you try to mimic the nature. So you have to understand the nature, you have to look into that in deep rooted way and try to find the solution from the problem itself. Problem means doesn't take a pen and paper, you should not write by your own. From the nature, from the society, try to take up a problem, address the it has more societal awareness. It will indirectly benefit the human. So that is the idea. You can see that, please share that link to that.
So let's begin with the presentations. The first paper ID is 118 by Jagdish Malsani in online mode.
Follow the order.
Jagdish sir, you can start now. Session. Share your screen.
Screen, share the screen.
Sir, please share the screen.
First of all, I would like to thanks to ICAITPR and College of Engineering for giving this wonderful opportunity. So, my name is Jagdish. I am pursuing post-graduation in ES University at Bangalore. So, the type of level is small-scale CNN and models of COVID-19 anomaly detection and localization of test cases. And my guides are like Dr. T. Narayan of Australia. So this is the layered problem statement for literature surveys and data information architecture results of conclusion of reference. So in the problem statement, so nowadays COVID-19 has been a very serious threat to health organization in terms of detection and its treatment. So generally COVID-19 most affects on humans. So common methods are we are using CT scans, X-rays to analyze the submitting this data. So there is no pre-processing based on deep learning models. So I'm taking some related data sets like memorial data sets. So they are
Sir, Jagadish Reddy sir. Sir, one second. Please maximize your screen, sir. Not audible.
It's enabled slide.
Maximize your screen, sir.
sorry,
Slideshow.
format showing some screens.
Slideshow or
Slideshow,
enable?
sir.
Slideshow, enable slideshow.
Enable your slideshow, sir. Yeah.
Press F5.
Press F5, sir.
Sir, I pressed F5, sir. It's showing format full screen, sir.
Okay, you can continue.
Okay. Don't waste it. Continue.
Continue, sir.
This is the data information. So, this data set was shared with the SIM. It is a data combination. First, the images are a diagram format. So, I resized the images diagram format to normal JPG files using diagram memory. So, I resized it to 56 pixel images and 512 pixel images. These are the 4 different classes having the type and test for a number of images. So this is our model architecture. We are taking the input as access. So doing some pre-processing techniques and data augmentation, and then some pre-trained models and our proposed CLM model to detect which type of information present in the test access. So this is my proposed CLM model. So I can have one of 21 convolution layers, followed as normalization maximum coding. So here we are using P-by-P and 4x1 filters and using the activation function as algorithm softmax. So initially I am using less number of lens layers, so it gives the less parameters and model size. After flattening the data, also I am giving 3 more lens layers. After the final lenses, for an activation function as softmax because it is a multi-class classification problem. So these are the results. I got for 256 pixel images. So this is my proposed CLM model. These are the different types of pre-trained models. So I got 84 as training accuracy, 83.56 as testing accuracy. So if you compare with different pre-trained models, section these are giving me somewhat more accuracy, 85, 84.50 and 82.90. And you can see here our proposed model are performing a little bit more compared to the our pre-trained models. Here it has only 11 million parameters with 42 MBCS. So you can see for action this it is 67 million parameters and 287 model weights. So our proposed CLM model is like 6 times smaller than the pre-trained model. So this is the using replacing the 256 images to 512 images and write different pre-trained models. These are the results. So we can see this is my actual data. It is an invalid data. We can see this code level having only 7.63% of images. So I did some image data generated. So I added some images to the trainer test stream. So like that I already have 120 images to the and I run the model prediction period. It gives the And also this is an object detection problem. I am using your method for object detection. So what is opacity means like chest X's are normally filled with A. So in place of A, so it can replace with some fluids, some bacteria, viruses. So you can say see that some aging part here. So this is called the opacity, means infection runs. We are so these are the 4 types. The boundary forces are already given in the data set. So based on the IOR score, means intersection over given us I predicted the boundary forces for the infection chest X-rays. So I am using YOLO different model weights like YOLO smaller weights, YOLO medium weights, YOLO larger weights, and YOLO extra large weights. And I got compared to that, I got more true positive values for YOLO with the larger weights. Here, true positive is nothing but it's opacity boundary forces are correctly predicted. False negative means when growth is present but model fails to predict the opacities. So my conclusion is that my proposal CMR is performed well compared to the remaining 3 type models having less parameters and model size. So our 256 pixel images are performing better on 35 over images. And if you balance their data outside classes to overfitting the model, so plain images are performing better compared to the normal images. And YOLO V5 larger weights are giving high true positive values compared to the remaining YOLO V5 weights. So the main aim is to help for radiologists to predict which type of infection and chest X-rays with more accurately. So in future, next research project they can do like using different pre-processing techniques to improve the accuracies in terms of accuracies, and also changing the some optimizers or changing the learning rate, running the model with higher number of figures, then maybe change the performance of the model. That's it.
So, ask the questions. You can ask.
Better can I move there so that he can listen? Yeah. Few questions are there for you. Which activation function, either ReLU or softmax activation function, has contributed to your performance?
Softmax are there, sir. For normal, I am using rail activation function to reduce the vanishing gradient and exploring gradient, sir.
So, how it has contributed to the performance?
Yes, sir.
What aspect?
Recently released in Canvas, sir. So these are the 4 classes. So there is no freely reset model, sir. Based on this data, sir. It is a new data set, sir.
Is there any comparison table for relevant activation, softmax activation functions? Have you shown?
So generally, for each convolution layer, I am using activation function as well, sir. For final layer only, I am using softmax, sir. Because it is a multi-class classification problem.
Okay. So, any information loss when you convert from DICOM to JPEG?
Yes, sir. Like age, genders, hospital names, like pixel also some reduces, sir.
Then what image processing techniques you have used to enhance the or restore the image?
Play with techniques to normalize the normal images to place, sir. So improve the quality of the image.
Okay. So, as the image data you are converting into JPEG and you are collecting only pixel information, which is a numerical information, how do you bring the class labels to that?
It's like pixel is like values between 0 to 25, sir, 255. So, if you give up out, I am taking the input as 256 by 256 by 3 channels, sir, to the convolution layer. So here after that line means it converts all images into what is array.
No. How do you bring the class class labels to the data? That's what my question is. Okay. Okay. In your feature scope, you mentioned only by enhancing the pre-processing techniques, normalizations, you want to enhance the performances in identification or detection of the anomaly. Is it so? It seems to be little vague in your thought process of feature scope. Okay, try to enhance that. Okay, thank you. All the best.
Audience, any questions?
Any questions from the audience?
Thank you, Jagdish Reddy sir. ID number 95 is there?
Is there? Online is there?
Yes, sir.
Can you start?
Yeah.
No, not now.
It's 95. 95. Oh, very very important.
You can start
Sir,
now.
I'll give you.
Yes.
Just give me.
Please share your screen.
Actually, morning session.
Yeah, you can continue.
Ask her.
Please max page your screen.
She's in ask her.
So, first of all, I'm from start. So today I'm going to present my paper on deep learning-based model for the detection of Parkinson's disease through voice data. So first of all, let's have a quick look about what is the Parkinson's disease. Or first of all, we'll talk about the brief abstract for this. Like if we talk about machine learning, deep learning, or in particular artificial intelligence, it has shown a tremendous advancement in the field of health diagnosis particularly. And therefore it's providing a better way for healthcare, and also we have to detect many kinds of diseases, be it the breast cancer, be it the lung cancer, Alzheimer's, Parkinson's disease, etc. So in my work, we have created a applied feature network for the detection of Parkinson's. So there are certain issues in my data set which I would like to discuss, like the number of incidences and the number of attributes. So I will discuss it in the future slides, but there is class and class problem. So that means we have the number of classes 1 more than the number of classes of the other neighbor. Also, we have done some kind of pre-processing, and I will discuss it in the coming slides. So our proposed model has achieved accuracy of 99.12%. So, if you talk about the Parkinson's disease, it is a neurological disorder, and it has been seen that after Alzheimer's disease, it is the second largest neurological disorder which is seen in the world today. So, if we talk about different kinds of symptoms, there are the voice impairments, the tremors, poor balance, anxiety, but the researchers have found that 90% of the people who suffer from the Parkinson's disease have speech problems. So, we conclude that the voice deterioration, it is the underlying symptom of the Parkinson's disease. These are some types of the literature who have worked on the same data set which I have worked on. So, like Parker et al., he has done some various things in the software, and this was the first time that Julio flew factor data transform is we have different features, the volume features, we have everything features, we have some fetch and other features. So this was the first time that these two WC features were introduced. Also, he has done feature selection technique, MRMR, which is called as the minimum relevance, maximum relevance, and minimum reduction.
You can go for proposed methodology. You can go for
Ma'am, one second.
You can go for proposed methodology.
Okay, sir. So, the technique is that first I have taken the data set from the UCI machine learning methodology. Then I have done the lead sampling technique, which includes more sampling. We could also run the other sampling, but the thing is that deep learning requires huge amount of data. So for that, we have done the lead sampling technique, and after that, the data has been transformed into the new data set. After that, we have
Nisa, I have few questions.
Yes,
What deep neural network technique you have
it's
employed?
a neural network. It's not a convolutional neural network, not LSTM. It's simply, see, I have shown my model over here that it's a kind of simple neural network where the OPC not having selected in the first, the hidden previous, fourier, and the answer layer. So it's not a kind of convolutional neural network or LSTM or RNN. So it's a basic
Okay.
neural network.
What is the data set size where you have acquired the data set?
So this is the data set size. The data set which I have used has been taken from the European machine learning network. And I have also mentioned the reference over here.
How many attributes and how many records are there?
See, this is a picture. So I'm showing you this. The number of instances, that is the number of rows are 756. The number of attributes are 754. In which the number of labels of instances of mark is 554 and the label is 192. So this is the data set information.
So what resampling technique you have applied in that?
What sample technique? Simply I have done the word sample in the Python where the number of, for example, if you see this data set, exponential data set where there are 554 one labels and 192 zero labels. So it's constant as you can see. But when I have done the word sample, it simply means that I have both samples being zero labels. That means I have replicated it. I have just used the library word sample and I have done the first sample.
Okay. 1 minute, Nisa. How do you conclude that min-max normalization will benefit your data set normalization? There are many normalization techniques.
Yeah, that's a good question. So this I have already mentioned it's an existing literature. This data set has used MRNR. I have used this data set earlier where I have applied the machine learning technique. So in that case, I have used recursive feature evaluation technique and MRNR. But when I compared the results of both section techniques, it was found that MRNR has shown the better results than the RNN. And also, I have studied many papers where the MRNR has a significant estimated results as compared to any other.
So have you compared with any existing techniques the performance?
Yes.
Only your algorithm performance metrics only you have given. There is no comparison with the existing algorithms.
So the comparison is shown in the data, but actually
Have you mentioned any table there? No.
No, I haven't mentioned the table, but this existing literature is all about the same data set. So here is the accuracy of 86%, here is the accuracy of 95.15%, here is the accuracy of 96%, and here is the accuracy of 95.39%. These all accuracies are on the same data set, and I have obtained accuracy of 99.92%.
Okay, Nisa. And there is no feature scope slide what you want to enhance. Okay? So try to put your effort in that direction. Okay? Thank you, all the best.
Thank you.
Next question.
130. ID number also, sir.
Let's get on with our next presentation by paper ID 120.
Paper ID 120. This was
Okay.
yeah. Okay, sir.
Sir, should I?
Yeah, yes, please.
Very good afternoon to all. Myself Dipali Lodi from ICAIT's Extra Engineering Institute, Kolhapur. The topic of my presentation is single identification, analysis with SVM and GMM classifier. This is a layout of my presentation. I will give an introduction, discuss the database, the SID system, acoustic features related to singing voice, the classifiers, the results, conclusion. finding the singer verification, many areas can be explored with singing voice, and one such major area of analysis of singing voice is singer identification. Singer identification involves automatic and accurate recognition of singing voice. It involves coordination of the vocal organs, the vocal throat, the coordination of the vocal tract. All this together creates a proper synchronized singing voice. So the singing voice is basically the function of these vocal organs. Every human has a unique characteristics, and this characteristics together gives the voice a beautiful characteristics. And this is what is the paper presentation all about, to explore the characteristics that govern the singing voice. Before we proceed into the depth, there's always a question, is there a difference between speech and singing? Definitely there is a big difference between speech and singing. Speech is a use of natural way of using the vocal organs, whereas singing is a controlled and precise organization of the vocal organs. And that results into singing voice having wide range of frequency, large voice duration exists in singing voice as compared to speech. Singing has higher harmonics, also fluctuations in fundamental frequency exist only in singing voice. The pitch range is, for normal speech, goes from 80 to 400, singing extends from 80 to 1000. And therefore there lies the difference between the acoustic features also. So the acoustic features which I have explored in my paper not only focuses on one vocal organ, it is comprising of both the vocal organs, it's comprising of both the vocal organs, the glottal source as well as the vocal tract. So the glottal source features which I have considered is the pitch, vibrato, and vocal tract related features which are extracted are formants, timbre, and harmonic spectrum. Let's first look into the database. The database I have used for singer identification is the Bollywood songs. We know that these days Bollywood songs are the most, influenced among the internet explorers. We are downloading a lot of songs. There are many music listeners. So Bollywood song is major source for music. And years together, years after, this database is going to go on increasing. And hence, research in this direction is going to assist proper systematic organization of these songs. Though these databases are extensively available, there is no existing corpus which gives us the calpella section of singing voice. My research work focuses on calpella section of singing voice, which is not having any background music. So manually, I have extracted the calpella sections from the songs and created a self-developed database on which my research is existing. And how that is done. So it is for this I have shown a structure of the singing voice. Usually it is observed that major of the songs usually start with some prelude music, then comes the mukha portion of the song where there is no background usually observed, and then comes the interlude and the antras of the song. So usually the mukha portion of the song is observed to be having less accompaniment of the background music, and this portion is where it has been extracted for extracting the exact acoustic features of the singing voice. This is the list of my database. So 14 female singers have been explored. The database not only restricts to the recent or to the old singers. You see, this database varies right from the old singers to the recent singers. Most important characteristics of the database is that there's a large span of songs which has been covered. So on an average, my database covers 16 years of singing span, ranging from 10 to almost 25 years of singing span of singers has been covered. This is the male database. So 17 male singers have been explored. So total the database has 626 songs. In segment level, it is covering 1,367 segments. This is the entire singer identification system. So it starts with the database, which is the calpella songs. A 4-fold cross-validation has been performed. The data has been then, some samples are given for training and then for testing through the 4-fold cross-validation. In the feature extraction, 4 features are extracted, unique features: the formant, the harmonic spectral envelope, vibrato and timbre. Then dimension reduction has been performed by applying PCA, and further the data has been given to the classifier. To begin with pitch, pitch has been explored by using the substrum technique. This is the complete pitch of all the 31 singers from the database. The first 14 corresponds to female, the later 70 corresponds to the male. When the plot was done, it gave a clear distinction that the female singers always have higher pitch as compared to the male singers, and this was the very first distinction to differentiate between the male and the female singers. The next feature was vibrato. Vibrato is one of the most beautiful characteristics of singing voice. This vibrato exists in the sustained tones of the singing voice, like we have ragas, when the singer says this kind of tones, there is a fluctuation that happens in around the pitch of the singing voice, and this is completely absent when we come to speech. So vibrato is one of the beautiful characteristics, and since I have taken all the professional singers, this vibrato is bound to be prominently existing in all the singers. And this, the other feature is that this vibrato has been extracted. The papers which are based on vibrato have been researched in a way that the singers are made to sing generating the vibrato. But in my research work, I have extracted these vibrato portions from the calcula sections, and then I have worked on it. It was observed that, so this is an example of how the vibrato extraction was done from the pitch contour. And here's the plot of the vibrato sections observed. The red dots are for the female, the blue ones indicate the male, and there is a quite distinction observed in the characteristics of the singers. The next feature was formant feature. Formant feature is basically related to the spectral characteristics, which is the spectral peaks of the sound spectrum. So the feature that was explored here to extract exact formants was the wavelet approach. So using the wavelet approach, different subbands were identified, and from these subbands, the formants were extracted, and here's the plot of the formants. And because of wavelet and because of multi-resolution analysis of wavelet, you could see clear identification of peaks from each subband was done. That resulted into exact identification of the formants. Here's the plot of the formants for all the singers from the database. Yes, this definitely is an overlap observed among all the singers from the database in the region from around 3 kHz to 3.7 kHz. Why is it so? Because this indicates the formant singing band which exists among all the professional singers. This band exists, is bound to be there for professional singers. But there are some distinct bands which are especially observed in the higher band that results into or contributes into identifying the singers. The next was harmonic spectral envelope. This is a complete novel feature which I have developed here from the spectral envelope. So using the LPC approach, the spectral envelope was computed. This spectral envelope, which is shown in the black one here, was then reconstructed at the harmonics of the singing voice. So the pitch was identified for this segment, and the harmonic vector was created as shown here, and this spectral envelope was then plotted for these harmonic instants, and that resulted into a new envelope which I named it as the harmonic spectral envelope. What is the beautiful characteristic that was observed about this harmonic spectral envelope is what? Was that this is a plot of one of the female singer, and this is the plot of all the harmonic envelopes of one of the male singers from the database. When these plots were done for all the segments of this female singer, it was observed that there was smoothness, uniformity, there was no erratic variations. So this was completely contributing to unique identification of this female singer, and this was true for all the singers of the database. There was a unique characteristics envelope curves observed for each of the singers that contributed to as one of the important features in identifying the singers. And this is the plot of all the spectral envelopes from all the singers of the database. The next feature was timbre feature. Timbre is basically contributing to vocal tract, spectral features. So it contributes so the feature that I explored from the timbre were two features, spectral roll-off and spectral flux. So spectral roll-off indicates the maximum energy from the spectrum, whereas spectral flux relates to change in the shape of the spectral signal spectrum. The Gaussian mixture model. The purpose for going for these two and the principle on which these two features classifiers work is entirely different. SVM is basically a discriminant classifier, whereas GMM is a probabilistic classifier. So the results obtained with these was shown for different combination of features also. So a different combination was tested, timber formant, HSE, and third was with all the features that I have used. It was observed that the accuracy went on increasing with more and more features added into the system. Moreover, the other observation was that SVM has given a best performance as compared to the results obtained from GMM. Combining other model comparison, performance parameters is accuracy, F1 score, and one more parameter that was tested was the performance computation cost, which was involved in these classifiers. So for that, SVM was one more time tested with another kernel. So once it was done for RBF and one for polynomial kernel, and GMM was tested. The computation cost, as seen here, GMM gave the least computation cost as expected, whereas SVM is involving high computation cost, over which RBF was good as compared to polynomial, and overall polynomial also gave poor result as compared to RBF. So RBF was found to be best as compared to polynomial. So this was the complete analysis. Concluding the work, so the work was presented with multiple acoustic features. Unique individual features failed to contribute, but multiple acoustic features, yes, they contributed significantly in identifying the singers. Two classifiers were tested. SVM was found to be completely outperforming GMM here, and RBF kernel was found to be superior over polynomial kernel. This was the conclusion of this particular research. These are some of the references.
So my question was go to the previous slides. So where RBF and polynomial.
Yeah.
So which parameter has contributed to perform well for RBF kernel than polynomial kernel?
So
What do you identify?
Yes, sir. When polynomial was first tested, I need to identify the degree on which my polynomial kernel would perform best. I observed that for a polynomial degree of 6, my polynomial kernel was performing good. But above 6, there was lot of convergence problem which my polynomial kernel was giving, and it was not identifying the singers.
So why not you have used linear polynomial?
So basically the features of singing voice, they are not having non-linear characteristics. So linear type of kernel would not be supporting for that. I need to go for kernels which are non-linear kernels. So I need to go for RBF or polynomial. And as we know, polynomial involves a lot of computational complexity because it involves exponential. The exponential, could say, data set increased as we went into higher and higher order, and that was clearly revealed in the
And go back to the data set in the segments.
Yes.
Table.
Data sets.
Go back to slide number, I think.
Yeah.
This one. See, no.
Yes. Yes.
So do you find any uniformity in the number of segments?
Yes, sir. This.
So see, the number of singers are different, songs are different,
Right.
number of segments are different.
Yes.
When there is no uniformity,
Yeah.
how do you bring the comparison among these segments?
Yes, sir. That's the reason why I went for F1 score. Because F1 score is applicable for, it is an imbalanced data. My data is imbalanced. And that's the reason why I have compared the classifiers.
Where is the
F1 score I have shown, sir, already in the comparison.
Sure.
Yes, sure. Because accuracy is not, could not say accuracy is best when it is imbalanced data.
Yes.
And that's the reason why I have gone for F1 scores. One minute. This, I have proposed even the comparison with F1 score.
F1 score, even we can apply for balanced data.
Okay.
It is not meant only for imbalanced.
But when it is imbalanced and when you are comparing the classifiers, F1 can give you good comparison result as compared to only discussing with model accuracy.
So any numerical, we can have F1 score.
Yes.
So for not only for imbalance.
Okay.
So my suggestion is better you think of how to make it uniformity in the number of segments.
Okay.
Then try to do. Otherwise, with the normalization, if you don't do,
Okay.
bring up to the same scale,
Okay.
the
Fine.
comparison will be always.
Okay. Okay.
Huh?
Okay. Sure.
And you have not proposed any future scope for your work.
Yes, should I
But
suggest?
I appreciate your work in this direction. Huh?
Thank you.
Good.
Thank you. Thank you.
All the best.
Thank you.
You have class.
Hello? Sir, paper ID 126. 126. Sir, is I audible? Paper ID 126 is there.
126 is the next
Can you start now?
Already? PPT?
Yeah, start now. Online, sir.
Yes.
Online?
Paper ID 126. Can you share your screen? Yeah. Yeah.
So this is the outline of today's presentation. So multiplication operation has become a commonly used operation in digital applications. In this multiplication operation, we will have partial product generation, partial product reduction, and final addition, where the partial product reduction stage consumes because of that the power consumption is very high, and it limits the speed of the complete multiplier circuit. So in order to reduce that propagation delay, in order to reduce the propagation delay of the multiplier due to this partial product reduction stage, compressor circuits have been introduced such that the overall power or delay decreases. And in addition to this, we have applied even approximation techniques on the compressor. The approximated compressor has been placed in the multiplier circuit such that the overall power and delay have been reduced. The multiplier that we have chosen here is the delta multiplier, and the application that we have performed here is this multiplier we have used for the image multiplication.
Go to the next slide.
Pixel
Proposed
multiplication
method.
has been performed. So,
Go to next slide.
It's an announcement, sir.
Proposed method.
12 minutes, 10 minutes only presentation.
Ma'am, you have 10 minutes only.
okay, sir.
Proposed methodology. You can go.
Yes. These are the journals and conferences that we have referred. The problem statement is we need to reduce the power and delay of the circuit, multiplier circuit. Generally, the compressor circuit is like this, where we will have 4 inputs x1 to x4, 2 outputs carry and sum, and C in and C out are the incoming and outgoing carries of the succeeding and C
are using for image multiplication. So the two images that we have taken are these two images, cameraman and Veena, and when we have implemented image multiplication using our proposed multiplier, the image multiplying the images are like this, and the PSNR values are shown in the previous. This is the proposed multiplier. When we use the proposed multiplier, this is the peak signal to noise ratio that is obtained. The particular conclusion, in this work, what we have done is we have applied approximation technique on the 4:2 compressor, and this approximated 4:2 compressor is placed in the multiplier circuit. Total 18 compressors are placed in the multiplier circuit, and this is simulated in cadence virtual tool. All the circuits are simulated, and delay and power values are calculated. Finally, Python code is written for image multiplication, and the images are multiplied using our multiplier. And these are the references that we have used for performing this work.
So, Lavanya,
Yes, sir.
will you move to the slide number 30? So, which parameter in your proposed approach has helped you to enhance the PSNR value? What is your observation?
Okay, sir. Whatever the, as I said,
So,
the proposed multiplier has been placed in the proposed multiplier is used for performing multiplication of 2 pixels of the images.
only that parameter has helped you to enhance your PSNR value?
Yes, sir.
Okay. So, which approximators has helped you in your approach? Is it software or hardware or whatever the circuit based approximation?
Circuit based approximation only, sir. So if it's yes, sir, circuit based approximation. In that also we have used truth table based circuit level approximation.
Okay, probabilistic pruning. Can you little explain about that? What
Yes,
you have
yes,
done in that?
yes, sir. Yes, yes. So if we take, let us suppose. So if we consider this is the existing 4:2 compressor, sir. So probabilistic pruning is nothing but removing irrelevant blocks or irrelevant interconnections. Such, let us suppose if you are removing any of this wire, that means this connection will be lost, and the interconnecting wire will also be disconnected. Like this is connected to this multiplexer also.
No,
So we will be
probabilistic pruning. I am asking probabilistic pruning.
Yes, sir.
So,
So different times we will see how the power is reducing, how the delay is reducing. Different combinations of circuits will be
so
removed.
no proposed methodology. There is no proposed. I mean, feature scope methodology you have written for that? No.
The future scope is here I have not mentioned, but this multiplier can be used for if we take neural network, we will have weights and inputs. So we can use this multiplier to multiply the inputs and weights.
Okay, ma'am. All the best.
Okay, ma'am. Thank you.
Okay.
Next 150.
Scan message in that.
I'm sure. Sorry, yeah. Sir, GS Reno 027
Is that outside?
Yeah,
Got it.
got it. Paper ID also.
It's been copied there.
Forward, backward, highlight. Right.
So good evening. My paper title is COVID-19.
Yeah.
So COVID-19 diagnosis using HRCT images. So myself actually, myself is Mansoor and BS1 also participated in this one. So the layout is a abstract introduction and right. So actually, the motivation for during COVID-19, my mother also infected with COVID. So we took the hospital. Actually, we did RT-PCR test. But due to some doubt, we went to the hospital. They referred for HRCT test. But at that time, I realized that RT-PCR test is also not fully accurate. It is accurate, but due to some at that time in the initial stages, the kits are not fully available. At my village, hardly 20 to 50 testing kits are available per day. So we went for HRCT test. So at that time, I thought that okay, why can't we automate this HRCT test using available whatever the data? So we collected the data. Actually, this is the previous. Actually, why to think about HRCT test? So I referred to some previous paper. So at that time, I see that in one paper. So in CT images, if there is a patient affected with the COVID-19, there are some changes in patient's lungs that can be identified using different radiographic images, like you can use X-ray images or CT images and HRCT images, which gives you more high resolution images. So we can consider HRCT images for diagnosing COVID-19. So, and there are some other papers also there, but their accuracy is 86.7 and 89.5, which is very less because predicting some medical disease needs high accuracy. So, for better results, I went with the transfer learning approach. So, transfer learning approach is nothing but some model is already developed for some different scenario. So, why can't we use same model for different problem? So that's what transfer learning do for us. So I considered 4 models. So I progressed to work in data collection, data pre-processing, and transfer learning approach which I followed, and finally I evaluated results for different models. Now first I collected data from KJ dataset. There is some dataset for HRCT images available for public use, and it contains 3,840 images at that time when I developed the model. So from that I considered 2,842 images, and in them, so these are for training, and 400 images for testing and 400 images for validation. So this is the sample data available. This is the COVID and this is normal image. So first, in data pre-processing, first we resized the images to 224 by 224 pixels, and we did gamma correction, which helps in enhancing the contrast of the images. Okay. So how actually you can gamma correction is nothing but we can raise the each and every pixel value to some power. So we can consider a fixed size power like 0.5, 1.1, 1.2. So based on this ratio, we can enhance the contrast. So how to get a good contrast, good gamma value? So we used some approach. So we calculated mean value of each and of all the pixels, we use that mean value to raise the contrast level of the images. Okay. So this is the mathematical formula. So actually this is the original image, and for this original image we applied some ratio power. So that ratio we calculated using this formula. So now coming to transfer learning, already some model developed for some data, different data. We can use this knowledge, that this model, for solving problem on different data. So how to do that? Simply by removing the output layer, whichever present in the existing model, pre-trained model, we can say it a pre-trained model. We can remove the output prediction layer and we can replace that output layer with our current, our own output prediction layer. So for that, we considered most popular networks like VGG16, ResNet 50, InceptionNet, MobileNet. Every model is having their own advantages. Okay, so and each model will run for only 20 epochs, and whenever there is no improvement in validation loss for continuous of 5 epochs, we are early stopping. We are doing early stopping. So that can save the training time. That's the only advantage actually. So the proposal model, actually we are taking input image. Okay, the input image can be COVID infected or normal. So we have the pre-trained model. In this pre-trained model, we are removing output layer. This output layer, we are going with global average pooling. Then we are doing batch normalization. Batch normalization helps in reducing the training time. Without batch normalization, if we do training process, it will take more epochs. So we can reduce the number of epochs using batch normalization. Simply, what can be the minimum range? We can fix some bounds. That actually batch normalization do for us. Then final layer, we can first we can have a convolution layer and we can drop out. We can add a dropout layer. Dropout layer helps in solving overfitting problem. So what is overfitting? Your training accuracy is higher, but your validation is giving less accuracy. To solve this overfitting problem, you can drop some of features extracted by your model. Then finally, dense layer. Dense layer is our predicting layer. So this is the binary classification. So that means you can either have COVID positive or negative. So binary classification. So the dense is 2, and we are applying softmax. What is softmax? Softmax is an activation function. During this all the layers, we have activation of ReLU. Okay. So ReLU is nothing but something you if some feature is not contributing anything, that is suppose it is in minus, it will bring everything into 0. Something is there, so above 0, the value is retained. Okay, so above 0, value is retained. Below 0, we can bring to 0. That is ReLU. Softmax activation in output layer will get a 2D image. Actually, we are doing 2D image. So to bring it to one dimensional, we can use softmax. In one dimensional, you can have all the probabilities. So here we have 2 things. What is the probability to say this image is COVID positive? What is the probability to say this image is COVID negative? So we can have these 2 values. So we can get this one dimension using softmax. So after this, we will get some value. Based on this value, you can now predict either it is COVID positive or negative. So evaluation. So these are the accuracies and loss for the training images. These are the accuracy and loss for validation images. For all the images, InceptionNet, MobileNet, VGG16 and ResNet and CNN. We developed by following the paper of CNN. We developed our own CNN model, just basic CNN model. So we consider total 5 models for transfer learning. These 4 are pre-learned. This is recreated just for testing. So just basic CNN model, nothing is there. Just by the paper of the convolutional layer of neural network definition, we added some convolutional layers and batch layer normalization and activation function, some CNN, and we got this accuracy. And evaluation for classification problem, I'll come back actually. So evaluation for classification problem can be determined using these matrices. F1 score, precision and recall. Precision. So precision tells you in what rate your model is predicting true value, true positives. So you can more focus on this precision. And recall, how much best it is predicting that if the so if F1 score is a combination of precision and true positive. So we are getting the inception net recall is 1. That means so it is if there is a negative patient, sorry, positive patient, it is not saying he is negative. So completely it is predicting accurate for this. So we can say that is required in COVID prediction, because suppose some person is already infected, but your model is saying he is not infected, he will roam outside. That is not designed designed for our model. So we can see that insertion is good, and we got this confusion matrix. So as I said, for testing we do total 400 images, 200 for COVID, 200 for normal. So out of 200 COVID patients, every patient image is predicted as COVID positive and 0 negative. Coming to normal patient, 4 patients are predicted as positive, 196 are predicted as negative. So conclusion, we can using this model we can say that inception net based model can be used as an alternative to COVID diagnosis, and we can further improve. Actually, HRCT images also gives you the grade, how much the patient infected. So we can work on that. So we can also predict the level of infection in lungs.
See, CNN is proposed to be the best model coming to the image classifications.
Yes.
How do you justify that inception net has helped you to enhance the accuracy?
Yeah. So inception, when convolutional neural network simply goes deeper into deeper, we can add more layers. But inception net, it is highly engineered, like not depth wise. It is wider in horizontal. So we can have different convolution, depth wise.
Which phase it is helping you to enhance?
Each and every time we have different inception points are more simply in inception net. So if we are giving any image to the model, first we can go with it goes in multiple, not in a single direction, 3x3 convolution, 1x1 convolution, and again 3x3, like that. The range is higher at the inception level itself. So with less number of features.
And what image formats you are getting in your database? Is it JPEG or is it ICAM? What kind of images you have?
PNG images. Yes.
PNG images.
Yes.
HRCT images or PNG.
Yes. Yes.
So any MRI based images,
Yes.
they are ICAM images.
Yeah.
So they need to be converted into JPEG, then you have to go for
I think JPG only, sir.
So initially it is
Yeah.
ICAM, then you have to convert it to JPEG. Okay? Good. Okay, all the best.
Thank you.
After 166. Paper ID 166?
Yes, sir.
Yeah. Can you start?
Yes, sir.
Start now. Share your PPT. Yeah.
So,
Yeah, start now.
good afternoon, everyone. Myself, Ragni Chaudhary from National Institute of Technology, Agartala, and I'm here to present on machine learning approaches for microscopic image analysis and microbial object detection as a decision support system. So here is my layout for today's presentation. So we all know that pathogens are disease-causing microbes which are found all over the world. Significant identification of such kind of creatures, microbes, from elementary forms of cell structure is very much important, and
Will you go to the proposed methodology, Amma, directly?
Yes, of course. So, sir, can I say the problem statement?
Yes, you can.
Yes, you can proceed.
Yes, thank you. The main challenges which are faced during the slide examination by the full pedagogical system includes computational challenges which includes time complexity as well as correctness in solution, and apparatus limitations which includes accessibility in apparatus accessibility and as well as high cost. So the proposed technique proposes the technique of automatic detection of disease causing microbes by deep learning techniques, where the module is the process is divided into two modules. The first one is classification by using CNN, convolutional neural network, with proper probability of prediction, and then the object detection, individual micro detection by YOLO, you only look once, which is an object detection technique of deep learning. So in case of classification, we have used the three kinds of data, micro data set, including Plasmodium vivax, Plasmodium falciparum, as well as tuberculosis bacilli. So it has been passed into convolutional layer, which analyzes the corners and edges of an input image. Then pooling layer is applied, which decreases the dimension of the feature map obtained after the processing of convolutional layer. Then it is passed into the fully connected layer, where the images are flattened and certain mathematical calculations are done. And drop-off layer has been applied here for few neurons to be dropped from the network for reducing the model size. And then lastly, activation function softmax is performed, for which takes actually the decision which information of the model should be fired in the forward direction. So in case of identification of microbes in slides containing red blood cell of a patient by YOLO, you only look once. So YOLO, the main guiding principle of YOLO is typifies the images into n grids, each having an equal dimension of region S cross S. After the clustering of different kinds of object is done, and prediction using bounding boxes is done, accompanied with object level, and as well as probability of the object is also mentioned. So we are using here YOLO version 5 model for because from literature review as well as from experimental result, YOLO V5 has confirmed to be better in case of our work, in this work, to be better identified. So YOLO V5 is open source project containing family of object detection method based on YOLO model pre-trained on COCO dataset. It has three layers again. First of all, ICAITPR diagonal backbone, which is formed by incorporation of cross-stage partial network into diagonal, which integrates the gradient change into feature map, and it decreases the parameters as well as increases the speed and accuracy of the algorithm, and increases the model size. Then the image is passed into the named portion of the YOLO V5 model, which is path aggregation network, which boosts flow of information and increases the accuracy and efficiency of localization of perfect object. And lastly, the image is passed into the final detector, which is head, where the three distinct visual sizes of feature maps are there: 18 cross 18, 36 cross 36, and 72 cross 72 for multi-scale prediction, which allows you to predict every object starting from small to big. So in case of this, we have first used level image software for detecting making the anchor boxes on individual microbes in each data set, and then class level are done on this and passed into the model for training purpose. So here 200 image data set of different three classes of microbes are considered, and training is done batch wise. So 25 batches are trained, each with 8 images to be done. classes in the data set. F1 score is the harmonic mean
Next
of
slide.
division and
No,
cross.
next slide.
Next slide. Next slide.
So these are the results of my test image. The first graph is precision versus confidence. The second is recall versus confidence, and third one is precision versus recall. We can see that with the increase of recall value, precision is decreasing. As we are increasing the true positive value, we are also increasing the true negative, the false positive value also. So with the increase of recall, precision is decreasing. And the confusion matrix is representing the probability of the predicted classes related to the actual classes, which denotes the performance of the used algorithm. So these are the results, the test image results, which the YOLO algorithm has predicted well. From the first image, we can see that all the micros in the slide has been predicted, and these are one kind of micro. In the second image, we have mixed up two kinds of micros together, but YOLO V5 has not performed well in this case. It has only detected one kind of micro here, and the same in case of tree also, it cannot detect wholly the three kinds of micros together. So the main contribution we can see in this work is that combination of CNN and YOLO for validated classified detection, RBC micro detection using YOLO in a finite amount of time. Graphical data presentations will serve as reference for future research, and lastly the comparative visual representation of different classes of micro with detection in one slide, all the classes of micros in one slide. So as we all know that deep learning approach is emerging technology in technological field. So it would serve as reference solution for field level methodology decision support system. And as we have seen the failure in detection of multiple micros within a single slide, it can be avoided by training with more epochs, accumulation of large number of data for training, and as well as we can increase the productivity of the algorithm by data augmentation also. So it will ensure the hurdles to be overcome. So these are all my base paper references which I have used in this presentation. That's all for today. Thank you.
Very good, Amma. And hope you are not from the computer science background, but you have applied all the computer science latest techniques.
Yes.
Do you know what criteria that YOLO algorithm is used in making n grids? What criteria? Is it size or what criteria it is considered?
Sir, YOLO algorithm is dividing the image into n grids according to the size of the image.
One thing, you have taken the data set only 200 images. Any deep
Yes,
learning techniques, we need minimum 10,000 to 20,000 images. Then only the
Yes, sir.
accuracy.
But sir, for this data set, I needed RBC related data set. So I have found 200 data sets. So I think that's why the results are this type.
So the accuracy values won't come if you don't take the larger data sets.
Yes, sir.
That is the fundamental point.
Yes.
That is the fundamental point we need to consider. Then we need to adapt other methods instead of this. But anyhow, from a non-computer science background, you are doing this effort. I am appreciating you.
Thank you. Next, 185.
180.
180.
I think this is the last presentation.
Take.
Is it BTEC or MTech? Huh? BTEC. Fourth year? Go ahead. Go to the.
Good afternoon. Myself, Satyam. This is our title of the paper. Myself, Satyam, currently pursuing BTech in ECE, 4th year. This is our layout. Coming going to abstract. If we
Any guidance for your paper or abstract or project? No. From your college. Have you mentioned his name? No.
No, sir. Guide has informed only mentioned your name.
Okay, then okay, good.
If we find initial state of the brain tumor, we can save many lives and we can save minimal cost of hospitality. This paper aims in identifying 6 different classes of brain tumors at an early stage. Brain tumor
Go to the problem statement directly.
these are the existing
Okay.
techniques and their drawbacks. Problem statement. We have problems in segmentation of tumorous cells and detection of tumor. We implemented this problem by image pre-processing technique, and using convolution neural network, we have detected a tumor and classified into different classes. This is our block diagram. We have divided this project into training and testing stages. We train the data and we test the data and we find the accuracy. Our proposed technique has 3 methods: pre-processing, future abstraction and convolution neural network. We have taken real-time dataset of 20 MB which covers almost 200 images, and we have taken it from CADI website. This is the sample of our dataset. Class 1. If the brain is doesn't affected by tumor, we have classified it into class 1. If tumor attacked the brain, lower right part, we define it as a class 2. Similarly, class 3. If the tumor is on left lower part of the brain, lower middle part is class 4. If brain contains of many tumors and left higher part is class 5. One or more tumor containing in the brain, we define it as class 6. This is the input image. Pre-processing. We do the pre-processing to the input image. Pre-processing is nothing but clean and prepare of the image. In our project, we resize the image into 128 into 128 pixels. Future abstraction. We extracted the futures using edge detection technique. This is the central movement formulas. By this, we have calculated the 1, 2, 3 orders. After calculating the central movements of order 1, 2, 3, using the formulas, this means the number of futures obtained by this method is 182 futures. After future abstraction, this is the output. The central movements of MRI image. Neural network training. The output of the future abstraction goes to the input of neural network. The input layer contains of 192 futures, and output contains of 6, which means 6 classes. This is the neural network training. We have used back propagation algorithm in neural network training. If we given input image as this, the output will be displayed as class 1 or class 2, class 3 or class 4, class 5 or class 6. By this method, we have achieved the accuracy of 97%.
Okay, initially, let me appreciate you as a student from BTech has come forward to present this paper. So, I am appreciating, give him claps. So, this is the starting stage, don't worry.
Yes, sir.
So, a lot of questions will be there normally. So, what segmentation techniques you have used? One, my question. And second thing, what is the type of image data set you have taken?
Type JPT.
No. Initially, one thing all of you has to remember, any medical data set, through MRI it is coming, it is a DICOM image. So, DICOM here sequence of images we are going to get, not one image. Okay? So that need to be converted into JPEG. Then you have to play with your algorithms. Okay? And another is the pre-processing technique. We have vaguely said the denoising techniques we have to apply. So what denoising techniques we have applied, that we have to decide. Okay? So what kind of noise type it is? Suppose if it is a salt pepper kind of noise, we have to apply median filter. So the type of noise is very, very important to identify. Okay? That gives the classification more proper. Otherwise, whole your procedure goes out. Okay? So with this I can say, and whenever you want to apply CNN, that is a deep learning technique, you have to apply minimum 10,000 to 20,000. Otherwise, accuracy levels, whatever we are getting, are not available. So good, I appreciate your effort. All the best. So, let me congratulate all the participants and the audience and particularly the organizers. So, with a lot of patience, you are here. So, any technique you are saying good, okay, try to compare with the existing algorithms. That is one. And what parameters is influencing that algorithm to perform? Then you can understand the logic behind the algorithm. So, which will help you better in your further scope. Okay. This all the best.